the focus of this session is going to be on upper ontologies, their origins, their characteristics, and we're also going to have an introduction to GIST, which is the upper ontology that we develop in-house at Semantic Arts. I'm Dylan Abney. I'm joined with Pell Olson and Peter Winstanley. We're all ontologists at Semantic Arts. I'll say a little bit about Semantic Arts for those who are unfamiliar. We're a consultancy with about 30 applied ontologists and semantic developers. Semantic Arts has developed or completed over 100 projects in the past 25 years since its founding, mostly focused on helping clients transition from an application-centric data architecture to a data-centric one. I'll say a little bit more about that in a bit. And for us, building ontologies isn't only an academic exercise. We've got a lot of combined experience building ontologies in a number of different domains, ranging from HVAC to government to financial services. A little bit of a roadmap for the discussion here. I'm going to start by leading a discussion on ontologies in general, say a little bit about that, and then I'll kick it over to Pell for a dive into the topic of upper ontologies. That'll really be our focus. And then we'll finish things out with a discussion of GIST that'll be led by Peter. Again, that's the upper ontology that we develop at Semantic Arts. If we have time for Q&A, we'll do that as well. Okay, so starting with some background on ontology in general. Here, we wanted to start by thinking about how we tend to make sense of the world. As living things, we communicate with language, and language gives us a way to express classification. We can start to group things under different terms. And this is something that we see across the animal kingdom. Even blackbirds can classify and communicate threats. And over time, the more we use language, the more we improve our language skills. And we start to go beyond just mere classification of things. And we start to make generalizations about the features or properties that things in these classes happen to possess. So how might we define ontology? There are a lot of different definitions out there, and you can kind of argue about how best to define ontologies. This is one definition that we could get started with that I think is a pretty good one. It's a structured way to organize and describe what exists in an area of interest and how those things connect to each other, what properties those things bear to one another. And so what does an ontology look like? Here's just a simple example that we could start with. You can see a number of different boxes on the screen here. These all represent different classes or types of things, and they can range from being fairly general or abstract, like living thing or non-living thing, down to things that are more specific, like dog. And you can see represented here different relationships between the classes. So for instance, we have a blue arrow connecting dog and mammal, and that arrow represents a subclass relationship. So dog is a subclass of mammal. That just means that all dogs are mammals. You can't be a dog and fail to be a mammal. Part of what it means to be a dog is just to be a mammal, right? And so that's kind of a mundane fact, but it is a fact that holds between these two classes. You can see that relationship holds with a lot of these different classes. All animals are living things, all mats are non-living things. Another type of relationship that holds between classes could be disjointness. So that's represented by the red arrow here. And what that means is that you can't be a member of both of these classes at the same time. So to say that animal and plant are disjoint just means that you can't be both an animal and a plant. Another fairly mundane fact, a fact that we all know, it's kind of common sense, but it is something that can be represented. And once you start to build these relationships between these classes, you're really starting to codify the meaning of these terms, right? What it means to be a mammal is to be an animal. And in fact, we can start to develop more complex definitions of these terms by citing the superclass of the term, and then also saying something that makes it distinct from other things. So for example, if we wanted to define what it is to be a triangle, we could say, well, it's a polygon, that's its superclass, and it has three sides. So that's what makes it different from things like squares, for instance. Another thing we can start to do once we've got an ontology like this in place is start to model data underneath the ontology. So we can take things that are out there in the real world and start to model them according to the ontology, like this is Frank, my dog, and he's on his mat. We can say that Frank is a member of the class dog, and Frank, his mat, is a member of the class mat. So that's something we're able to do with this model in place. Now, why would you want to develop an ontology for your enterprise? There are a number of different reasons. Some of them are listed here, but one of those reasons is to codify a shared vocabulary. So developing a shared vocabulary is an important thing, particularly with larger organizations. It's common to have multiple terms referring to the same thing across different divisions or teams or applications or their underlying databases. And developing an ontology helps to ensure everyone's speaking the same language, which is ultimately a key for data integration. And one thing we often see is that concepts that are key to a business, maybe it's a term like customer or project or product, it's tempting to think that since these terms are used so frequently that the person down the hall from me has the exact same meaning in their head. And it turns out that people often have slightly different concepts in mind. And for this reason, it's important to get on the same page and figure out which meaning is best. And that's what will go into the ontology and serve as a basis for reasoning. Reasoning with an ontology serves at least a few purposes. First, you can check the internal consistency of your ontology to make sure the axioms you've developed aren't logically at odds with one another. Second, you can make sure all of your data is consistent with the ontology. For example, if you have two disjoint classes, like we saw on the previous slide, plant and animal, and you've asserted that Frank is both a plant and an animal, then a reasoner is going to catch this error. And finally, you can use reasoning to uncover deeper insights about your data. So some derived facts may be more mundane, like if somebody's a person, that you can derive that they're a living thing. But often reasoning can generate facts that aren't at all obvious given the initial data set, and sometimes logic will yield surprising results. And then the final reason you might want to create an ontology is that it's a step towards data centricity. Often when we start working with clients, they'll have what we'd call an application-centric architecture. It's common to see dozens of applications used for various purposes, all with different data models or schemas, and these databases are siloed from one another. By creating a single ontology to represent all of your enterprise data, you can start to break down silos, and your organization can really start to take ownership of its data. And with that, I think I will kick it over to Pell to start the discussion of upper ontologies.